What's up people, this is Prachuja Biswas and thanks for tuning into my channel. Today we will learn something about chemistry and this is atomic models. Talking about atomic models, let's revise what we have done in the last two lectures. In the last two lectures we talked about mainly some experiments and three subatomic particles which are constituents of the atom. The three constituent atoms include an electron, a proton and a neutron. The electron has a charge of -1, a proton has a charge of +1, and neutron has a charge of 0. This charge or this Q is equal to the fundamental charge, that is 1.6022 into 10 raised to the power minus of 19 coulombs. Also, the electron has around 1840 times less mass than that of the proton and the neutron. That is, the mass of the electron is around 9.1 into 10 raised to the minus 31 kilos, whereas for the proton it is 1.7 into 10 raised to the minus 21 kilos. So we can approximately take the mass of electron to be 0, and in relative to that the mass of proton and neutron can be 1. These relative mass units are called the atomic mass unit and or the unified mass. So we are talking about AMU, which has been, if you have studied atomic structure beforehand, then you must have heard about this term AMU or U. We say that the mass of a proton is equal to 1 AMU or 1 U. Okay? What does the AMU stand for? AMU stands for atomic mass unit and U stands for unified mass. Its AMU has been designed in such a way so that our calculations become easier. 1 AMU is equal to the mass of 1 proton, that is 1 AMU is equal to 1.67262 into 10 raised to the power minus 27 kilograms. So this is 1 AMU. This is also the unit of 1 U. The U and the AMU have the same meaning in this type of problems. Now let's move on with the model of atoms. Now first we need to understand that why model of atoms was so important. Well, when observations are made through experiments, it was then decided that if there is an atom, then it has to have a structure or a model behind it. And therefore, thus, to explain the structure, various types of model came into being. Some of the models were not able to explain the stability of atoms, but two of these models were still taken into consideration. The first model was the J.J. Thomson model and the Ernest Rutherford model. The J.J. Thomson model is in 1897, when J.J. Thomson model came out, it was very well taken into the consideration by the scientific society, and that's why we have to discuss in that kind of thing. J.J. Thomson in 1898 proposed that an atom possesses a spherical shape. An atom possesses a spherical shape and its radius can be approximated to 10 to the power minus 10. So its radius can be approximated as 10 to the power minus of 10 meters, in which the positive charge is uniformly distributed. So if I take the positive charge as yellow, rather the positive charge as light blue, then the positive charge was like this. Right. And the electrons were embedded into it in such a manner to give them the most stable electrostatic arrangement. So if I take this to be, let's say, red, then this was something like this. The red were the electrons, which from now on will be denoted by this, and this blue part was the positive part, or I can say protons. This was before the time proton were discovered. That's why these type of models came into being. Now there is a special word which was used here called electrostatic arrangement. The electrostatic arrangement means that the electrons cannot be just randomly put into that spherical shape or that positively charged sphere. The electron had to be put in such a way so that these arrangement was electrostatically stable. Because we know that from our normal common sense that if there are two unlike charges, then they attract each other, and if there is two opposite charges, then they repel each other. So let us suppose that we have two charges, an electron and an electron. Then we know that these two will repel each other, right? Similarly, in the case of a proton, like we have a proton here and a proton here, then these will again repel each other, right? So this is very important that these electrons, the distance between these two electrons were in such a way that they do not repel each other, and if we can select two points like this, then distance between and then the electron density between them should be in such a way so that they also don't repel each other, right? This was postulated by J.J. Thomson, but obviously if we look at this and through our common experience, that how can a positive sphere like that stay in one place? It has to break down and go farther away because they will repel each other. This model was given different types of names like plum pudding, raisin pudding, or watermelon method, in which the watermelon method was a very easy to use name and thus was more popular. An important feature of the model was that the mass of the atom was assumed to be uniformly distributed over the atom. Although the model was not able to explain the overall neutrality of the atom, but was not consistent with the results of the later experiments. Right. After this, many experiments was taken place, but still this model was considered to be vague because of the two concepts that the mass of an atom was assumed uniformly distributed, and secondly, this atom could not stay in a well place for so long.